Good morning, everybody. Our project is about soil nutrient analysis. Here, this is the data which we collected from the Kaggle, where we saved in CSV file and we saved it in our local so that we can easily access through Jupyter Notebook. So now we'll go to Jupyter Notebook where we developed our project. This is our project. Here we imported some libraries as like NumPy, Pandas, Matplotlib, scikit-learn, etc. These are used for plotting the graphs, for calculating numerical data, for importing algorithms, etc. Here, this is the file of the text data where we collected from the Kaggle in the form of CSV file where we saved it in our local. This we uploaded in Jupyter Notebook. This is the data of the text. This is the description of the data where we can have mean, median, standard deviation, minimum, maximum, count, etc. So that we can use this where there is a situation we need to insert the data if we want. And these are the box plots. Some of the plots we have implemented in this project like box plot, elbow plot, silhouette plot, and endogram. Box plot is nothing but the graphical representation of mean, median, and mode. Uh, Here, the box plot for each and every attribute we see in our screen. This is the correlation of the data, where we have a relationship between the attributes. If the attribute is dependent on one on another or not. If the it in the sense if the attribute is dependent on another attribute, if there is any miscommunication between them, there will be a huge problem of getting less data. Should have minimum correlations so that we can have better accuracy rate. These are the samples. We define that the attribute line is greater than 100. Those data we printed here. This is optional. Here head defines, if we define head here, it means that we are collecting the data from the top. Here we are seeing the screen like top 5 rows are printed here. Head in the sense we'll collect the data from the top. Head of if we give here any value, it gives the data from 0 to that value, 0 to n minus 1 if head of n means. uh, Z score is applied for actually to remove outliers in the sense where we need to remove the missing values or null values where we are not using that values. We can remove that to get great accuracy. Here we imported k-means algorithm. These are the clusters and this is the cluster errors and this is the elbow plot. This describes how many clusters are there in the data. Actually, the feature variables of the data are like potassium, nitrogen, and sulfur, calcium, carbon, lime, etc. These are the feature values, and target variable is the soil moisture. Here, this is the dendrogram. Dendrogram refers that which attribute we use more uh, precisely. Means more frequently used attribute it defines. This is a Silhouette plot. This Silhouette plot defines the relation between two variables, how close they are, how close the attributes are. Coming to this is about centroids of that gaming cluster we saw before. Uh, Here we came to main algorithm, and that is random forest algorithm. Here we imported standard scalar from the scalar for pre-processing. We will train the data by fitting into it. Here we take criterion as entropy as we are collect as we are creating trees based on entropy. Here we created confusion matrix for both train dataset and test dataset, and this is the overall accuracy of this. This is the pure description of the random forest algorithm. There are some algorithms which will compare with the random forest algorithm. We append these algorithms, and this is a small code to perform those functions. Shuffle equal to 2, that means we can take attributes and shuffle themselves. We can take create trees there, etc. These are the accuracy rates for different algorithms. We plot bar graph of the accuracy and algorithms. This is the comparison graph. So this is our project about. Hope you understand. Thank you.